Hello everyone, welcome to Royal Palace online crash course classes. Today I am going to discuss about oscillations. In this video I will give lecture on oscillations. See, what is an oscillation? Means if a body moves to and fro, about a fixed point, we call it as one oscillation. That means it moves forward, goes backward like this, again come back. This kind of motion is called oscillation. For that one example we can take. The example is a body is revolving in a circle like this, and the foot of the perpendicular projected onto the diameter. This is the foot of the perpendicular. So I am drawing one perpendicular, projecting it onto the diameter. At time t is equal to 0, particle is here. After some time particle reached here. Now also you draw one foot of the perpendicular. Now you can observe this foot of the perpendicular. Now let us assume particle is here, foot of the perpendicular is like this. If particle is here, this is foot of the perpendicular. Now again if you observe this motion of this foot of the perpendicular, it started from here, it is reaching up to here, again coming back, again going back, again coming back. This is an example for oscillation. If acceleration is proportional to negative of displacement in oscillation, it is called as simple harmonic motion. If acceleration is proportional to negative of the displacement, if acceleration is always directed towards mean position. One more example for simple harmonic motion is simple pendulum. The simple pendulum, when it is moving forward, it has an acceleration directed towards mean position, because it always wants to come to mean position only. Body tends to come to rest at mean position. That is why this kind of oscillations are called simple harmonic motion. Example is foot of the perpendicular dropped onto the diameter when a particle is revolving in a circle. Now let us derive one formula in a very short manner. We will derive just for competitive exams. We will derive the formula for displacement. For displacement, let us take at time t is equal to 0, particle is here. After some time t, particle reached this point. Time interval taken is delta t, that means after t seconds. Now this is the displacement of the foot of the perpendicular. Foot of the perpendicular, initially it was here, now it reached here. So that means this is the displacement. Exactly opposite, this is the displacement. Now take sin theta. Sin theta is equal to y by r, where r is the radius. This is the r. From this you can write y is equal to r sin theta, and r is the maximum displacement the particle will do, that is y is equal to a sin theta can be written as omega t. Why? Because in already in rotating motion I told omega is equal to theta by time, angular displacement by time taken. This is formula for y. Now differentiate this with respect to time, you will get velocity. Velocity is equal to differentiate this with respect to time, you will get velocity is equal to v is equal to a omega cos omega t. Again you differentiate this with respect to time, you will get acceleration a is equal to minus omega square a sin omega t. That means this a sin omega t is again y only. So when acceleration is proportional to negative of displacement, we can call this kind of motion as simple harmonic motion. And next let us write the formula for time periods of different systems. Simple pendulum, time period of simple pendulum, this is important PUC question, so you already know how to derive this. So simple pendulum time period is 2 pi under root of L by G, where L is length of the simple pendulum, G is the acceleration due to gravity. If this simple pendulum, suppose in exam, if they ask simple pendulum is taken to other planet, whether time period will change or not, it will change because G value changes. If simple pendulum is kept in a moving elevator which is moving upwards, what is the time period? When it is moving upwards with an acceleration A, this time period I can write 2 pi under root of L by G plus A. L by G plus A. So like this many questions they can ask. This is the time period of spring mass system. Time period T is equal to 2 pi under root of M by K. And liquid column. When a liquid column is there in a U tube like this, in a U shaped tube, when liquid column is there, if that liquid column, if you apply some force, it undergo oscillation like this. Similarly, if you leave a bead here, it will undergo oscillation like this. So liquid column also undergoing oscillation. This delta, this H is the height of the liquid column. So time period is equal to 2 pi under root of H by G. Height means difference in height. You take 2 pi under root of H by G. And next, conical pendulum. Conical pendulum means a pendulum which is rotating like this. Pendulum will be rotating in y axis like this. This is the simple pendulum. This will be rotating like this. This pendulum will be rotating like this. So time period of that simple pendulum is 2 pi under root of L cos theta by T, where cos theta is angle made with the mean position, or otherwise the point of contact like this. Next, compound pendulum. Compound pendulum means it is a rod, or it is also called physical pendulum. It is a rod. When rod is oscillating, what is the time period? Time period is 2 pi under root of I by EMGL. So how we are going to derive the time period? You already know. We will take the force acting on a simple force acting on the particle will take, based on that we will calculate the time period. Let us see how to calculate time period if they are giving different bodies. Just calculate the net force. Calculate the net force. For that, let us take one example. Suppose there is a spring mass system like this. Spring mass system. The spring mass system, when it is present in air, what is the time period? So what is the force acting? Let us assume I applied some small force F. It has given a small displacement x. Then force acting will be equal to, force acting is equal to kx. Force acting is kx. Then according to simple harmonic motion, or according to Newton, we can write force is equal to m into a. M into a is equal to kx, right? And acceleration already we got minus omega square. This is restoring force. So here also I can take minus omega square a square sin omega t, and I can write minus omega square x, where x is the displacement. Here y was the displacement, here x is the displacement. So this is equal to minus kx. This x and x will get cancelled, minus and minus will get cancelled. Omega is equal to, you will get k by, omega is equal to, here you have to write mass, no, this is acceleration multiply with mass, omega is equal to k by m under root, this is 2 pi by t is equal to, 2 pi by t is equal to under root of k by m, under root of k by m, and time period is equal to 2 pi under root of m by k. This is how we are finding the time period. See, this chapter, oscillation chapter, is very simple and all formulas we can remember, but the main problem with this chapter is it can be linked to any other chapter what you have studied previously, both in first year and second year. We can link it. How we link, I will show in the next example. So here spring is present in air. Now what I will do, I will go to our last video. In our last video, what we have done, we have yesterday in last class, in last video, what we discussed about archimedics, we discussed about buoyancy force. Now let us immerse this spring in water, then see what happens. I will just immerse this in water and I will see the time period of oscillation, whether time period of oscillation will change or not. If I immerse this spring inside water, now it is totally inside water, it is totally inside, not a little part is also not outside, it is totally inside. Now in this case, what happens? Now again I applied a small force F for this spring and released. If I apply a small force F and release, what is the time period of that spring? Whether it is similar to m by k or it will change. So let us see what happens here. When I apply a force in this direction, kx will develop in this direction, because F is equal to kx, it will be always opposite to the applied force. When you compress, then force will be outwards. When you are pulling like this, force is developed in this direction. Restoring force will develop in the spring. At the same time, when body is inside a liquid, a buoyancy force also will act. So now what is the net force acting here? According to Newton, net force is equal to kx plus buoyancy force. Kx plus buoyancy force. Now kx plus buoyancy force have to equate to ma. Then follow the same method, then you will get time period of this oscillation. This you equate to m into a is equal to kx plus fb. Based on that, you can get the formula for time period. You know, a omega will be there, from that you can get. Similarly, if a cylinder is floating, or if a body is floating, a body of mass m is just floating on the liquid, I just pressed it and released. There is a body of mass m floating on the liquid like this, floating on the liquid. If I just press it through a small distance x and release, it started to oscillate, then what is the time period? So just if I press this, let us take x I pressed, buoyancy force will act on that, buoyancy force will be the restoring force here. Buoyancy force is equal to m omega square x. Buoyancy force will act on the volume which is inside only, volume inside into density of liquid into g is equal to m omega square x. This I can write volume is area inside, area into area inside into length inside into density of liquid into g is equal to m omega square x. If I press through distance x, this length inside will be x only, so this will get cancelled. Area is area, you know, area of that body you can find, area into density of liquid into g is equal to m omega square. From this you can find omega, again you can find, from this you can find omega, then again you can find 2 pi by t is equal to omega. From that you can get the time period. So this is how to calculate the time periods of different systems by using this method. The method is you have to follow Newton's law, calculate the net force, whatever may be the condition, calculate the net force, equate to m omega square x, then find the time period. And next important topic in oscillations every time they are asking at least one question from oscillation. The topic is damped oscillation. If you go for JEE Mains or NET, most of the examiners are concentrating on damped oscillation. So, what is meant by damping? What is meant by damped oscillation? Means a oscillation which is under the influence of opposite force and whose amplitude is decreasing with time, that kind of oscillation is called damped oscillation. The oscillation which is under the influence of resistive force, because of which whose amplitude decreases continuously. This is A naught, this is A1, this is A2. Because of the resistive force, suppose a simple pendulum is oscillating, I am applying a resistive force, air resistance is there, because of that, that simple pendulum will move forward, backward, and slowly its amplitude decreases and finally it reaches to the mean position. So, the amplitude, the oscillation is said to be a damped oscillation when the amplitude of the oscillator decreases like this, amplitude goes on decreasing and finally it comes to rest. Then resistive force acting on the oscillator is proportional to velocity. If you remove proportionality, you will get Fd is equal to Bv, and this is the restoring force developed inside the oscillator. Suppose spring is oscillating, restoring force will be minus kx. So, the formula for force I am writing here, m into A can be written as d square x by dt square. 2 times if you differentiate the displacement, you will get force. So, from this again next step, I am writing m towards this side. So, you divide this by m, and if you solve this, you will get displacement is equal to A e to the power of minus b by 2m into t cos omega dash into t plus phi. Here what is omega dash? Omega dash is the new angular velocity of this oscillator. Initially we will give omega, but what happens that omega slowly decreases and it becomes omega dash. You can see omega dash is equal to k by m minus b by 2m whole square under root. This k by m is nothing but omega what you have given. So, damped oscillator what happens, its amplitude decreases. Then what they will ask in your question, what is the amplitude after some time. So, this you have to remember, A is equal to A naught or AD is equal to A e to the power of minus b by 2m into t, and based on displacement, based on velocity is a omega cos omega t. This also I can write it as omega into a square minus y square, because cos omega t I can write as 1 minus sin square omega t. So, from that I can write omega into a square minus y square. Similarly, we can write potential energy. Potential energy is mg into y, where y is the displacement. Y value right there. Y value is a sin omega t. A you can write here a acceleration. M a y. So, acceleration is based on that you can find potential energy. Otherwise, you can take force acting. You can take minus m omega square x is the force acting. If F is proportional to x, then what is work done? Work done is integral of F dx. So, integrate this, what you will get? You will get this as half m omega square x square. So, this is the formula for potential energy. X value you can write it as a sin omega t, a square sin square omega t. Similarly, you can write kinetic energy. Kinetic energy is equal to half m v square, half into m into v. V is a square omega square cos square omega t. What is the total energy? Total energy is half m omega square a square. That is the total energy of a simple harmonic oscillator. So, this is all about oscillations. This is very small chapter, and this is very small chapter, and it has a lot of applications in other chapters also. Just I have given 2 examples. You can connect it to any other chapter and you can find the time periods. So just as a example I given, you can start solving the problems based on oscillator. Sometimes they will ask what is the time taken for amplitude to become half, means y out, right, a by 2 sin omega t you can take. If it is starting from main position, we will take a sin omega t. If it is not starting from main position, we will add phi, where phi is called initial displacement. Where phi is called initial displacement. So based on that, you can start doing the problems, and mostly you concentrate on damped oscillations. In damped oscillation, they will ask after what time. They will give the value of B, 2 and M also. M is the mass of the oscillator. And after what time, what is the amplitude, means amplitude becomes a naught by 2. So this is the amplitude, it is decreasing, it becomes a naught by 2, after what time they will ask. So this is all about oscillations, and so quick recap of formulas are given. You can start doing the problems. If you have anything to comment, you can leave in the comment section. If you have any doubts, you can send through our WhatsApp group, or you can write in the comments also. We will discuss in the next video. Thank you everyone.